So, okay. A bit of who am I. Before I worked in this as a security, I worked for 8 years as a Java developer. After walking around with those crazy folks, I decided it was time to dedicate myself to something serious. I built the first BMX trick sensor in a weekend. It's actually a fun project. As usually, someone calls me and says that has something that he can't do, and I usually do it just because I can. Objectives. Some time ago, I read something on a blog saying that as for time goes, when you try to crack passwords from other people, you get better at it. It sounds weird, so I decided to test that for myself. One of the issues that I found when I started this was that blind brute force takes a lot of time. It usually goes around trying huge word lists, starting to work on permutation of stuff, and this consumes time. Over time, I also noticed that this, besides efficiency, you start repeating yourself. And usually when you start thinking about this, you want to go the other way around. So, less words, try not to repeat yourself, remove the duplicates, and as you go on with this, you start noticing that you need more information about the hashes or the passwords that you're cracking it than the hashes itself. So when somebody says that, I've heard recently that you don't need an expiration date on a password because if it's a strong password, nobody will find it. Nobody chooses a strong password, not even we. So that's, well, I won't say the bad word. So usually people choose passwords based on their personal information, their interests, their native language, blogs, visited websites. All of this can be compiled into word lists, and if you use restrictions, you'll reduce that word list even more. So all this source of information and the source of the words and the target's information will compile itself into a word list. I repeated myself for here. So my use case, I've Googled around and I found a website that was kind enough to publish all the user information, including the hashes. I won't say that it was a university. And yeah, it was a fun thing because they have 15 users in there. The hashes were all there. I think they still are. And some of them were actually professors. So I decided to use this. So my first step was identify the algorithm, create the users, create a word list based on user information. And here was my hardware. I'll skip this. Tools, everyone knows them, knows this one. The advantage of using the CPU, although by the end of this I've noticed that the CPU is really something you can get as a plus. So to efficiently use a brute force, you can build this, I built this square, which is basically lowercase and uppercase, the digits, and I've shuffled around with this to try to reduce the number of permutations with stuff like this. Start with uppercase, try the middle of the lower letters because it's easier to remember, and end with numbers because we all know how people choose their last date, something like that. The results were something like this, and you'll notice that some of these numbers are actually social security numbers. Okay, so I'll skip them fast. I have a 2 meter long board in my house. So when things start to get tough, I usually do these small designs. What I'm trying to do here is establish a pattern between the number of layers in the password and their components, and the time that I need to go over all the permutations. Some of the permutations I have here went from 10 seconds to 2 hours or
10 seconds.
Okay, so okay, what's not a password? Then this is the last step. when you go over all this and you start to go over the brute force, yeah, you identify what's not oppressive. And I'm over, right? So. Magnify.
So the last one, please.
Oh. Oh, the last one. Well, the last one was. Actually, the last one was that I managed to crack all the passwords in. The total number of hours that I used my computer to crack all the 15 passwords was 2 hours, basically. And the last one had 14 characters.